All right, we're not given an explicit formula in number 3, and we're given a graph of the first derivative, so that's a little bit different. And we're told that the function itself, f of x, is continuous on this part, and that we have kind of an initial condition there. And so we're gonna have to work backward. So a few things we can see that we have are zeros at 1 and 3 of this situation. So that's where our local max or mins are going to be, right? At 1 and 3. And then we can also, so we can develop pretty easily an equation for this, and we can do it a couple different ways. But notice we go from 2, -1, and if we go over 1, we go up 1 here, and same thing here. If we go over 1, we go up 1, and then if we go over 1 again, now we're going up to here. Okay. So let's look at number 3. So a few things that we can see. We can set it up this way. We know that we have our first derivative. We had roots at 1 and 3, and then we might say, well, we don't know what that value is there. But we do know that where x is 0, we equal 3. So we can put that in, and we see if I multiply that through, we have this situation evaluated at 0, so a must be 1. And then, of course, we can look at it that way too. Okay, so we have this value. Now, of course, just like we were doing for these, where we took the derivative to get to here, well, now we need the antiderivative of this function. So we take the antiderivative here, and of course we add 1 and then divide by that. So we have x to the n plus 1 over n plus 1, sorry. There, same thing here, but part of that cancels out, and then we have this situation. And then, of course, it's an indefinite integral, so we have the plus c. Well, the plus c is our initial condition, right? If we have f of 0, I put in 0 there, there, and there, all I'm left with is c, and we're told that that's 4. Okay, and then, of course, we can take the second derivative as well, which is just the derivative of this initial piece. So that's the 2x comes from there, and then the minus 4. And we can create our chart. Okay, so now the important thing to note here is that we're going from 0 to 4. The 0 of this function right here is actually pretty ridiculous to come up with, and we'll see that in a minute. But it's not really of concern to us because we're limited from 0 to 4. Okay, but just to note, it's over here approximately -1, but not quite. But we do have these other points here. Clearly from our graph, we knew that 1 and 3 were in there. We have those, and then also from this second derivative, we see that 2 is an inflection point here. So we'll look at that real quick. So we're given this initial graph that looks like this, and from that we can, well, so that's one way to look at it. The other way is to look at it in this form, and then we can see from there we took the integral, and we got this bit here. And so you can see that our local max lines up with this point, and our local min lines up with this point. And under here, we're decreasing, right? And from here up, we're increasing, and from here out, we're increasing as well. So we know that we've done a good job with that. Okay, and then of course we've got our second derivative, which tells us from here to here, from this point backward, we are concave, and you can see that. And then from this point forward, we're convex, and we can see that. Now the ridiculous part that I was going to show you is that this is the actual root here. And we can see that lines up right there. approximately 0.822, but it's a complicated process to figure out a root of a cubic, and so, but the good thing is we don't need that for this particular problem because we're only going from 0 to 4, and we want to sketch that green curve from 0 to 4. Okay, and that should cover number 3. For number 4, we'll go on to parametric curves, and that'll be in the next video.